During today's lab, you would have been determining the enthalpy of neutralization of sodium hydroxide with hydrochloric acid and the enthalpy of neutralization of sodium hydroxide with acetic acid. This is going to be done through a process called calorimetry. The first step in doing this is to determine the mass of each of the solutions that will be mixed. We will begin by placing an empty cup on our balance, and the cup weighs about 4.4 grams. We're going to go ahead and tare the balance so that it reads 0 so that we can easily determine the mass of the sodium hydroxide solution. Take the cup off the balance and add sodium hydroxide to the cup. Then place the cup back on the balance and we see that our solution has a mass of 54.164 grams. Next, we need to do the same thing for hydrochloric acid, so we place an empty cup back on the balance. We tare the balance back to 0 and then remove the cup. Add the hydrochloric acid, and then place the hydrochloric acid on the balance. 51.014 grams is the mass of hydrochloric acid in our cup. The next thing we're going to do is determine the temperature of the hydrochloric acid solution, and that will represent our very first point on our graph of temperature versus time that we'll be doing. So we take the hydrochloric acid, we place our temperature probe in the hydrochloric acid solution, and our initial temperature will be 24.54 degrees Celsius. Now we're going to get out our calorimeter, which is a large insulated metal container, and we add our HCl to that and sit it inside the container. Place the lid on it so that it's fully insulated, and then we're going to add our temperature probe on top. At 20 seconds, we read the temperature of the hydrochloric acid solution, and it turns out to be 24.45 degrees Celsius. We continue this over the course of the next couple of minutes, and we read the temperature at each time, at 40 seconds, 60, at 80, 100, and then at 120. At this point, we quickly remove the lid, take the sodium hydroxide solution, and dump it into the hydrochloric acid solution. Put the lid back on the container and get our time at 125 seconds. You can see the temperatures are starting to increase rapidly, and with 30 seconds, 135, 140, 145, and we just continue taking our temperatures until we reach about 300 seconds. We continue on. At 170 seconds, we've reached 30.91, and you see the temperatures are relatively stable at between 30 and 31 degrees, and we just let this finish out until we reach that final temperature and time that we're going to be measuring. At this point, you would have all of your data collected for trial number 1, and we would repeat this for trial number 2 and trial number 3 for the sodium hydroxide with hydrochloric acid. It works in exactly the same way, but you're going to get a different set of numbers each time. Then we would go back and we would start the experiment over with a fresh solution of sodium hydroxide and a fresh solution of acetic acid. We would perform exactly the same steps that we did in the first place. Measure the mass of the sodium hydroxide solution, measure the mass of the acetic acid solution, take the initial temperature, and then using our calorimeter, measure the temperature for the first 2 minutes, then mix the solutions together, and finish out by watching the temperature as it changes, first to a much higher number, and then as it slowly begins to diminish.